Hello, dear colleagues. I'm glad to present you results of our research, Holts Model of COVID-19 morbidity forecast in Ukraine, which was provided in National Aerospace University Kharkiv Aviation Institute in Kharkiv. In the 21st century, infectious diseases still remain a significant threat to humanity. From an evolutionary point of view, the emergence and persistence of pathogens of infectious diseases is inevitable, and any cellular form of life, including humans, is a target for parasitic microorganisms. In response for bacterial or viral threats, eukaryotic and prokaryotic organisms have developed defense mechanisms to counteract the pathogenic infectious agents, while the latter in turn reacted by developing counter-protection mechanisms to overcome host defense systems. The constant evolutionary arms race continues today, and therefore unpredictable outbreaks of infectious diseases remain a constant challenge for humanity. The outbreak of coronavirus infection COVID-19 is the largest recent challenge for the health system, and the rapid spread of the disease around the world is due to the many factors, and globalization plays a key role in the process. After the first reports in December 2019 of an outbreak of pneumonia in China, the new coronavirus quickly spread across all countries and continents. By the beginning of May 2021, the number of registered cases of SARS-CoV-2 infection amounted more than 163 million, and almost 3.5 million people died due to coronavirus-related causes. In Ukraine, according to official statistics, by the beginning of May 2021, more than 2 million COVID-19 infected were detected, and 38,000 deaths was recorded. However, the reported number of infected people is only a fraction of the actual number. Ukraine became embroiled in the current COVID-19 pandemic later than other countries outside China. The first confirmed case was reported on March 3rd, 2020 in a man who returned from Italy on February 26. The first death was recorded on March 13 in a woman who returned from Poland. And by March 24, 2020, the number of cases exceed 100. By April 3rd, 2020, 1,000. The process of detecting infected people in Ukraine continues to demonstrate not just but a significantly growing trend, which shows the daily number of confirmed cases of COVID-19. From March 24th, 2020, the first day of detection of first 100 cases, according to Ministry of Health of Ukraine. The COVID-19 pandemic in Ukraine is characterized by territorial unawareness, which is associated with different population densities, differences in communications, religion traditions, uneven migration flows, regional characteristics of the fight against COVID-19, and so on. At the beginning of the pandemic, the increase in incidence was observed in Western regions. The COVID-19 pandemic is an unpredictable threat to public health, the national economy, and social development that can have uncontrollable consequences and cascading consequences for all aspects of society. To successfully cope with the threat that has arisen, to reduce the impact on health measures taken to combat COVID-19 pandemic, it's necessary to respond in a timely manner to change an epidemic situation by introducing effective, scientifically based, adequate to current situation rational measures. Mathematical modeling is an effective tool for predicting the dynamics of the development of the epidemic process. With the help of modeling epidemic process, it's possible to solve the problem of predicting the time series of morbidity, identifying factors affecting the dynamic of morbidity, calculating the required proportion of vaccination, and proportion of diagnostics, medical image analysis, and so on. So the aim of the study was to develop a linear Holts model for predicting the incidence of COVID-19 in Ukraine and to assess the possibility of use it. The epidemic process is only a form of existence of infectious disease. And the direct driving forces of the epidemic process are the source of infections, the transmission mechanism, and the susceptible human body, which create a chain of successive infections, of successive infections. Without these links, the existence of the epidemic process is impossible. The biological hazard of the population is determined by the possibility of the emergence and spread of biological agents that are pathogenic for humans. In the case, the process of spreading pathogens in space and time, the distribution of cases among the different groups of the population, and the dependence of these events on various phenomena and processes occurring in nature and society are important. Therefore, no less significant are the secondary driving forces of the epidemic process, social and natural factors that affect the intensity and manifestation of the epidemic processes. Slowing down or accelerating its development. The exponential smoothing is a method for smoothing time series, the computational procedure of which includes the processing of all previous observations, taking into account the aging of information as it moves away from the forecast period. In other words, the older the observations, the less it should influence the value of the forest estimate. The idea behind exponential smoothing is that as we age, corresponding observation are given degrees in weights. This forecasting method is considered to be quite effective and reliable. And the main advantage of the methods is the ability to take into account the weights of the initial information, the simplicity of computational operations, and the flexibility of describing various dynamics of processes. The exponential smoothing method makes it possible to obtain an estimate of the trend parameters that characterize not the average level of the process, but the trends that have been developed by the time of the last observation. The method has found the greatest application for the implementation of medium-term forecasts. For the exponential smoothing method, the main point is a choice of the smoothing parameter and initial conditions. Identifying and analyzing the trend of the time series is often done by flattering or smoothing it. Exponential smoothing is one of the simplest and most common techniques for aligning a series. Exponential smoothing can be represented as a filter, the input of which sequentially receives a member of original series, and the input from the current values of the exponential average. So let X is a time series. Exponential smoothing of the series is carried out according to the recurrent formula, the second one on the slide. The smaller alpha, the more filtered and suppress the oscillators of the original row and noise. If we consequently use a recurrent relationship, then the exponential average can be expressed through the values of the time series X, as is shown on the slide. If earlier data exists by the time smoothing starts, then the arithmetic average of all available data or some part of it can be used as the initial value as 0. If earlier data exists by the time smoothing starts, so when making a forecast using trend models, it must be borne in mind that the model is rigidly uncourse and all time series data equally affects the forecast. If there is a need to give more weight to the new data, exponential smoothing can be used. And however, we noted earlier that exponential smoothing method doesn't give satisfactory results. If the data is monotonically increasing or decreasing. That is, it contains a trend. In such cases, the trend-based exponential smoothing methods can be applied. Simple exponential smoothing of time series containing trend leads to a systematic error associated with the lag of the smoothed values from the actual levels of the time series. To take into account the trend in a non-stationary series, a special two-parameter linear exponential smoothing is used. Unlike simple exponential smoothing with one smoothing constant, this procedure smooths both random distributions, disturbance, and the trend using two different constants. Holts model consists of three equations. The first one is a data smoothing equation. The second one is a trend smoothing equation, and the last is a forecast equation for the period t equals k. Here, A is a smooth value of predicted indicator for period T. B is the estimate of the growth trend. Alpha is smoothing parameter. Beta is smoothing parameter. And K is the number of time periods for which the forecast is made. The smoothing parameters alpha and beta are selected subjectively, that is by the forecaster based on the experience of previous forecasts, or by maximizing the forecast error. At larger values of the parameters, there will be a faster response to change that occurs. Since the larger the parameter, the more smoothing the data will be, and vice versa. If the smoothing parameters are small, which tend to zero, then the model's response to changes in the data will be weaker, and the structure of the smoothed values will be less even. For the experiments, data on COVID-19 new cases provided by the Center for Public Health of the Ministry of Health of Ukraine were used. Holts model for predicting the incidence of COVID-19 was implemented as a software product in the Python programming language, and the application includes both data on COVID-19 morbidity in the world, which automatically loaded from the Johns Hopkins University database, and more detailed data on Ukraine provided by the Center for Public Health of the Ministry of Health of Ukraine. Results of COVID-19 morbidity in Ukraine using Holt's linear model is shown on a slide. The results of the forecasting of incidence for 10, 20, 30 days shows that short-term forecasting for 10 days is the most accurate. Nevertheless, for use of practice, you can also use the results for 20 days, since such a forecast shows that will happen to the population after 14 days incubation period. So in this work, as a result of the analysis of various models and methods for predicting machine learning in order to predict the incidence rate and compare the results of calculations of each of the models, the Holt method was used. As part of the study, a linear Holt model was developed. The quality of the model was shown in the form of the size of the forecast error, and the graph was built on which you can clearly see the calculations on the predicted incidence of COVID-19 for 10, 20, and 30 days. On the basis of the developed model, the information system has been developed that allows analyzing the dynamics of the incidence of COVID-19 in the regions of Ukraine. The results of the forecasting of incidence for 10, 20, and 30 days shows that short-term forecasting for 10 days is the most accurate. Nevertheless, for use of in practice, you can also use the results for 20 days, since such a forecast shows what will happen to the population after the 14 days incubation period. So also I want to say that this is only a small part of our big project on simulation COVID-19, and more about it you can read in our project page. Thank you for your attention.